Hello everyone and welcome to this day's Pandas challenge. This is day 19 of 30. My name is Valentine and I'll be your instructor. In this challenge, we are going to be going through another set of Pandas concepts that will allow us to be able to perform data analysis or manipulation. So let's get started. The first thing that you need to do is to visit the description section of this link of this video and click on the practice resource link. That should take you to a page that looks like what you're seeing on the screen. Once you get here, you can click on the sample practice resource link, and then that should take you to the sample notebook. And then we can continue. Feel free, by the way, to pause the video and then get to this point, and also to other points if you feel like we are too fast in the course of this challenge. All right, once you get there, save this sample notebook as a copy by going to File, then save a copy in Drive, and then close this original one and use the new one that will open in a new tab. I'll be using the practice notebook because it contains a lot of challenges. If you're an after-work member, you'll get the chance to also practice with this notebook. But if you're just if you just want to exercise with just a few challenges, then you can also do the same thing. You can just use the sample notebook. No need for that. All right. So once we get here, the next thing that we need to do is to once we have already saved a copy, is to now go to the first section. So prerequisite, expand that and import the Pandas library using the code that you see here, import Pandas as PD. So we can run that, just run anyway. It should take a few seconds for the first time because normally you would be connecting your notebook to Google servers. Okay, so once that is done, we can then now start the concepts. I'm working towards how to just work with just different concepts when it comes to Pandas. So the first concept that we'll get to work with is deleting rows by condition based on specific column values. So for example, what does that mean? So what that means essentially would be, assuming you had this data set which contains information about just industry machines. By the way, we're just giving you just random data sets so that you're able to apply just these Pandas concepts in whatever context that you get, because data science, it's a field that's applicable across just many industries, and one of those would be manufacturing. So assuming that you have this data set and you wanted to get records that are not maybe that do not involve maybe a certain type, or it's a metalworking. In this case, we would need to select all the records that are metallic type, and then we negate that. We use the tiled. This is the tiled character. It's usually a character just above the tab key on your keyboard. And, that would specify those records that we would want, the ones that are not what we have set in a condition. So, for example, if we wanted to delete the rows based on a specific condition. So, first of all, we would get these we would get the rows which are in association with this condition. So first of all, we would set our condition, which is usage hours less than 700. So what we want is to get those records which are not usage hours less than 700, which which do not have usage hours less than 700, and then we get that. So essentially what that does is it filters for records which have values greater than or equal to 700, and that's what we get. We actually delete those records that actually have this condition as true. So if you run this, you will get records which essentially have usage hours greater than 700 or equal to 700. And this is a concept that you could use, or sometimes it's not necessarily straightforward, but you could also use it in some cases. Especially if maybe you would want to delete records, but now taking into consideration some condition. So I think, by the way, there are many other ways you can delete records based on a certain condition, but this is just one of those. It just involves just filtering. All right, pause the video and then work on the challenge. In some other situations, we might want to perform filtering using the lock method, but again, define a condition using the is-in method. So we could assume that we have this data set initially, which still contains industry machines, assuming we have these machines. And we wanted to get, first of all, records that contain, or we could define our condition using the is-in method. And we would want to get the records that have the type value as either metalworking or woodworking. So first of all, we would define that condition, as you can see here, and then we pass that to our lock method, or the lock method, for that data frame, and then we get now the filtered records. This is also another way of just performing filtering. Sometimes you might realize maybe using this is-in method is the most straightforward way. And you would perform such kind of an operation. Or in certain cases, when you're reading code someone else has written, you might see something like this. But simply what this means is just filtering, but now taking into consideration the condition that has been set using the is-in method. All right, pause the video and then work on the challenge. In the past, we also got to learn about how to drop duplicate rows or records. This is what we actually, in this case, just repracticing what we did. So in this case, we would have this data set, and if we wanted to just drop our records that are similar to previous records, we could just apply the drop duplicates function to the original data frame, and that would be it. But we could also specify what we mean by duplicates. If maybe duplicates have the same type, then we could define that inside the drop duplicates function as a list. But yes, so essentially this would just, they'll drop those records as such. Pause the video and then work on the challenge. In some cases, we might want to delete records by a particular condition, but again, we would still want to use maybe one of those techniques that not necessarily filtering, but we could use just a condition simply. So assuming again that we had this data set that contains industry machines, and we wanted to maybe define condition, or initially we could define a condition as shown. So if we wanted to delete those records that have the status column as active, we would define the condition as shown. So we enclose it in parentheses and pass that to the drop function. But again, we would want to specify the indexes, because the drop function would actually drop the indexes, that the records with the indexes that we give it to. So we get those records by this is a condition that we pass. We pass this condition to df, then we set the condition here. But we actually don't even need the parentheses, by the way. We may not necessarily need parentheses, but we pass now the condition to df condition, which will get essentially the records that have this condition as true. And then we get the indexes of those conditions. And then once we have done that, we would, pass that to drop function, which generally drops those records. So if we run this, we should get, like you can see here, this is inactive. So there's the record with index 1 would be deleted, as you can see here. And also index 5, it's not shown here, but it would also be deleted. All right, pause the video and then work on the challenge. In some cases, we might want to iterate through records that we have. This is a concept that we've learned in the past, but for more practice, we've provided it again. So assuming that you had this data set and you wanted to iterate through and perform some operations, we can use the iter tuples function, and we apply that to df to be able to get the records, individual records, and then use row to store the current item when it comes to when it comes to iteration. So once we have done that, once we iterate through all the records, we actually access the column name values using the position, the integer positions. Like for machine ID, the integer position, no, will it be that? Okay, I don't think it should be. This should be machine, should be 0. This should be 0. Yeah, this should be 0. Then 1, 2, 3. So integers should start, integer positions should start from 0. I think there's something that I did. Is it 0? Okay. All right. So 0 should give us the index. So if I run this, it should give us the index in that situation. Yeah. So this 0 should give us this index. Then machine ID will give us 1. The first column. Yeah. So accessing, sorry about that confusion. So to be able to access the machine ID column or machine name, you would use 0, then not 0, 1, then 2, 3, 4. So the different positions that we have here would help us be able to retrieve those values for the records that we have. Then we can print them out as shown here using a print function and an F string. Okay, all right. Pause the video and then work on the challenge. In some cases where we would want to investigate data and work to see which of the records are outliers, we might decide to use a box plot to just identify the values within a certain numerical variable that are outliers, that are way far from the majority of the points. So to create a box plot, we can use a box plot function, and then we pass a value, a list that contains the column names that we want to create box plot for, to the column parameter. So we pass this list to the column parameter for the box plot function. We can also set aside the grid to be false so that we don't have a grid. So if we run this, we should be able to see that we have the following information, so which is just basically a box plot. For operating hours, it seems we have an outlier for that particular case. So we can then use other techniques such as z-scores method, or we could also use IQR method to identify the outliers majorly. All right, pause the video and then work on the challenge. In some cases, we might want to use to perform some data preprocessing tasks that are quite specific or custom to our work. So assuming that we have this data set, again, this is a different data set that contains information about industry machines, and we wanted to convert maybe utilization rate from just what it has here to just a number. So what we can do is, to assuming that we just wanted to convert it to a number, we just wanted to remove the percentage so that we can perform mathematical operations to this column. What we can do is to write our custom function, which would essentially strip out the percentage sign. So that's actually what we do here. We define the convert utilization rate function, which would take in the column value, that's the rate, and then it would strip the percentage value. Then we divide that by 100. And yeah, so once we have, and it would be that value, that resulting value that happens after stripping of the percentage would be returned. So if we wanted to apply maybe this function to the existing column, we can then use the apply method, and we pass that function to that. Which should apply the function to all the columns, all the column values, and we then store the results to the original column name, so which we have there, and we can preview that, and we should see that our operation has been performed. So we have decimals in here instead of the actual percentage value. Pause the video and then work on the challenge. In some cases, we might want to concatenate or just bring the values of two columns together to form a single column. So maybe in some cases we might have first name and last name, and we wanted to have just one column to be able to represent both pieces of information, maybe a column like full name. So we can use this technique that we'll get to learn here. So it's a technique, again, that we've worked on in the past. So assuming we have this data set and we wanted to combine manufacturer as well as the model together to have a column called manufacturer model, then we can decide, first of all, to specify the new column name, which would be the existing first column that we want to have the value on the left. So that's manufacturer. Then we apply the cat method to that column from the string module, and we define inside that function the second column that we would want to concatenate with. So that's the model column, and we define also the separator, which is the dash. So we'll have manufacturer dash model. So it would be, let's say, ABC Industries dash L1 2 3 4. Then we preview the data set. All right, pause the video and then work on the challenge. In some situations, we might want to replace maybe some missing values that we have, maybe with a mean. Like for usage hours, we could want to replace the missing values with a mean, because it could be maybe that we've arrived at the decision that maybe that works best as the value that maybe that makes sense at most. The same case for condition, we could do that with mode. For condition, because it's categorical in nature, getting the mode of what we have in this data in that column would work best for the missing values. So assuming we had this data set and we check for missing values, and we see that we have the missing values for usage hours as well as condition, what we can do is to first of all calculate the mean, let's say for usage hours, which will store in mean values, and use the fill_na function to apply that method, and we set in place to true to have this operation that we have here applied in the original data frame, and basically essentially we would end up with the column value. So usage hours has 0 missing values. I think the best option, I'm not sure, because I'm just looking at this this data set should have probably something like if I check the size of it, shape, df shape, it should be 75 records and 24. That's like a third, more about a third. I probably maybe would use a different method, not necessarily the mean imputation method. Probably use something like maybe a regression technique. Could be a decision tree regressor for such a situation, just so that the records that are replaced are much more representative of the values that are likely to be missing for the specific columns that you have. But again, that's an option that you'd also explore. So you could always just work with both techniques and look at the implications of either of the techniques. And sometimes it could also take just some domain expertise after studying all of them. All right, pause the video and then work on the challenge. Ranking. So this is a technique that we can also use to be able to rank records based on maybe a certain order, or for the column values, or that is for a numerical variable. So assuming you had this data set and we wanted to rank records based on the utilization rate column. So first of all, we would need to convert what we have here to numeric values. So we could still use, remember that function, custom function, or we could still use this particular technique. So we just strip off the percentage sign and work with that value to rank. But again, once we strip that, it's still going to be a string. So we apply as type function and we set that we want to have that value as a float. And then we replace what we have here with now a new column called utilization rate numeric. And then we can use utilization rate numeric to rank by using the rank function and specifying how we want to rank from from the little values, from the greatest values. The greatest values will be ranked first. That's why we set ascending to equals to false. And we also set that we want to have that column as an integer. So instead of having 1.0, 1.2, 1.3, 1.5, 1. Or 2.5 or 3.5 values, we would have just integers for that column. And we create now a new rank column, and we display the output. So when we look at our data, we have our data is shown. So we have utilization rate. We could have actually displayed utilization rate numeric, which you could also do. We also just paste that here, numeric, okay. So you can also see that we have, and also you could also continue again at sort, but in our case, that the interest was more on ranking. So having a new column called ranking, you can see 95. We have 1, then 2, it's 94, which is the index 72, etc. But again, that might be helpful in answering some questions. All right, pause the video and then work on the challenge. Okay, we hope that you are able to have practiced those concepts. Again, with practice every day, you're able to get better and better at just getting to work on data analysis work of other projects, and also be able to review the work of others and understand how some analysis has been achieved. If you did love this learning experience, you found it valuable, be sure to give it a thumbs up. It actually tells us that we're doing a good job, and we've seen that quite a large number of challenges have received a thumbs up, which means we'll continue producing more of this content and also related content, maybe in relation to other libraries. And if you'd want to be informed when we post such future learning experiences, which of course inspires us to continue doing so, be sure to subscribe, and see you in the next challenge that will be on day 20. All the best in your learning journey. Bye-bye.